Now we are going to turn our attention to geometric sequences and series. And basically here the idea is that there is a common ratio between terms. In other words, you are multiplying to go from one term to the next. Now there are two key formulas here. The first one is the one for a sub n, finding the nth term. You have a starting point a1 and you multiply by r n minus 1 times. And then there is this sum formula to find the sum of the first n terms of this geometric series. Now personally, when it comes to these geometric series, I think sometimes it's quite a bit easier to avoid using these formulas just by doing these things by hand, as you'll see when I work out some of these problems. Because we're not going to be multiplying by a ratio r too many times, it's sometimes easier to write these things out by hand. For example, let's start with this first problem. We are beginning with 5 and we're moving on to negative 5 thirds, positive 5 ninths, negative 5 27ths. First off, yes, this is geometric, and we can tell that because we are multiplying by negative 1/3 to go from term to term to term. Notice when we multiply by a negative, our terms are going to alternate back and forth between positive and negative. In this next problem, it seems that we have two separate patterns going on, one for the numerator and one for the denominator. In the numerator, 5 times 3 is 15, times 3 is 45, times 3 is 135. So here we are multiplying by 3, and there is a ratio of 3 between those numerators. In the denominator, it appears that we are multiplying by a squared. So yes, this is a geometric sequence, and the ratio between terms is 3 over a squared. Now we're being asked to write the first 5 terms of a geometric sequence. We're told that the first term is 80 and that the ratio is negative 4/5. In other words, we're going to multiply by negative 4/5. We're going to have negative, and it turns out to be 64. When you take your 80, divide by 5, and multiply by 4, you get negative 64. Multiplying by negative 4/5 again, we're going to have a positive term. 64 multiplied by 4/5, 5 does not go in evenly into that 64. So we're going to have a fraction, and it's going to be 256 over 5. Likewise, our next term will be negative 1024 over 25, and our fifth term is 4096 divided by 125. All we are doing to go from term to term to term is multiplying by negative 4/5. In this next problem, we're being asked to find the 8th term if our first term is 4 and there's a ratio of negative 1/2. Quite honestly, I think it's easier if we just start with 4, multiply by negative 1/2 to get negative 2, multiply by negative 1/2 to get 1, and then negative 1/2, and positive 1/4, then negative 1/8, then positive 1/16, stopping only to check how many terms out we are. 1, 2, 3, 4, 5, 6, 7. We need one more term out, which will be negative 1 over 32. This is one place where I think it's a lot faster to do it this way than using a formula. Now if you were to use the a sub n equals a sub 1 r to the n minus first power formula, you would write a sub 8 is equal to the first term, which is 4, times the ratio of negative 1/2 to the 8 minus first, or to the 7th power, and that would then generate the negative 1/32. Personally, I think it's a little bit faster at times just to go straight with your understanding of what the variables here represent. In this case, r tells you to multiply through by negative 1/2 to go from term to term to term.